Hello guys, welcome back to our channel. So today we are studying with other chapter of MHT-CET Formula Marathon of 12. Before that we have completed of 11 and 12. So you can go and watch it for mathematics and physics. It will be really helpful for you. So till that time, please subscribe our channel, hit the bell icon and do comment. Let's begin with wave optics. The first formula of wave optics is n is equals to c by v. C is equals to lambda naught into v. So c is the speed of light. V is a frequency, nu is this is not V, this is nu, and lambda naught is a wavelength of light. Second here is 1 and 2 is n2 by n1. So it will be sine I divided by sine R. 1 and 2 is n2 by n1, which is mu1 by, this is mu1 by nu2, which is equals to v1 by v2, which is equivalent to lambda 1 by lambda 2. For a parallel beam of light in medium 1 incident on an interface with medium 2, it is cos I by cos R. This is the formula. Now, Malu's law. What is Malu's law? So it tells us about I2 is equals to I1 cos square theta. Now here, this is Malu's law. Now here, Brewster's law. We will get to know. So 1 and 2 is equals to theta b, means Brewster's angle, or it is equals to theta b is equals to tan inverse of n2 by n1. Now, let us begin with further going. The relation between path difference, change in L, and phase difference phi is. What is the relation? So relation is change in phi is equals to 2 pi by lambda into change in L. This is the relation between path difference and phase difference. Or one more formula we have of this is change in phi equals to y into d by d multiplied by 2 pi by lambda. So here change in L is equals to y into d by d. Like this way, you will get to know this. Now, condition for constructive interference in terms of path difference is, so now over here, it is change in L is equals to y and d by d. So change in L is n into lambda y and d, the position of wire bright fringe. So here y and it is n bright and bright fringe over here. So yn is equals to n into lambda d divided by d. Similarly, position of NIL. So n is equals to 0, 1, plus minus 1, plus minus 2, and so on. It is for dark fringe. It is for dark fringe. So change in L is equals to y and d by d equivalent to n minus 1 by 2 into lambda, which would be giving us y into n is equals to n into 1 minus 2 into change lambda into d divided by d. So this is the formula of constructive interference in terms of path difference. Now we have distance between any two successive dark or any two successive bright fringes. So let us know about that as well. So fringe width, what is the fringe width? That is W is equals to change in Y is equal to Yn plus 1 minus Yn. Yn plus 1 minus Yn is called fringe width. This is fringe width. So now W is equals to lambda into d divided by d. So now on the formula over here is condition for constructive. Let me write condition for constructive interference in terms of phase difference, that is phi. Change in phi. A change in phi n is equals to n into 2 pi So n is equivalent to 0 plus minus 1 plus minus 2 and so on. Now we have condition for destructive interference in terms of phase difference. So change in phi n is equals to n minus 1 by 2 into 2 pi. So n here will be n is equals to 0, plus minus 1 plus minus 2 and so on. Intensity distribution E1 is equals to E naught sine omega t. Here it is written as well. That means I'm writing E2 is equals to E naught sine omega t plus phi. The amplitude of wave phi is equals to 2 E naught cos phi by. So this all is the formula which will be really helpful for you all. Now when amplitude of wave coming from two slit different E10 and E0 same. At the center of the bright fringes, the amplitude will be E10 and E20, and hence the intensity is I max is proportional to E10 plus E20 the whole square. So this is important, proportional. Similarly, at the center of the dark room, the intensities will not be 0, but I mean is proportional to the square. So it will be I max on the form. This is also important. I mean is proportional to it. Where it is addition, where it is subtraction, because it is not 0. So now third formula over here which we have. So this is first, second third. I max upon I min is equals to E10 plus E20 the whole square divided by E10 minus E20 the whole square. It shows us that root of I1 plus root of I2 is not whole square. Just let me correct it. So now root of I1 root of I2 divided by root of I1 minus root of I2 the whole square. This is very important formula. I max upon I min formula. This is really important. The wave vector k and the angular omega are related as k is equals to omega by v. V is the speed of the wave. So this is first wave vector. Now let me second phase change phase. So phase change. Change in phi is k, change in x, which is equals to omega into change in x multiply this is divided by v. If wave is traveling in vacuum it is there. So k is equals to omega by c and change in phi is equivalent to omega into change in x divided by c. The wave is third will be wave is traveling in a medium having a refractive index L, and then it's k and omega s. So k dash is equals to omega by v, which is equals to omega v equals to c by n. This will be the formula we will get. Now, optical path formula we should know. So optical path is equals to V in vacuum is equivalent to nu in vacuum divided by nu in medium into d in medium. So here we get n into d in medium. So this is the optical path formula, and this is really important. A distance d traveled in a medium of refractive index n introduces the path difference is equals to n in d minus d. So d into n minus 1. This is also important formula. Now, single slit diffraction. Angular half width of central maxima is theta 1 is equals to lambda by a. Angular width of central maxima 2 theta 1 is equals to 2 lambda by a. Mth secondary maxima theta m nearly equal to sine theta m. So m plus 1 divided by 2 into lambda by a. M is equals to plus minus so on. Mth minima theta m sine theta m is equals to m lambda by a. Distance of first minimum from the center and of the central maximum. So y1 is equals to d lambda divided by a is equals to f lambda divided by a. Now we have width of the central bright fringe WC2y1 d is equals to 2w into 2 times multiplied by lambda d by a. In conjugate Fourier method, D is equals to root of D1 into D2. Now we have comparison of Young's double slit interference pattern and single slit diffraction pattern. So this is the difference. Now let us go one by one. Fringe with W, Young's fringe W is equals to lambda d by d, and W is equals to lambda d by A, except for the central bright fringe. So phase difference n into 2 pi, n plus 1 into 2 pi. For nth bright fringe we are talking. Angular position theta is n into lambda by d, n plus half into lambda by d. Path difference change is n into lambda, n plus half into lambda. Distance from central bright spot y, n into lambda d by d is equal to n into w, n over a single slit, n plus half into lambda d by a is equal to n w. For nth dark fringe, we have n minus half into multiplied by 2 pi. Here it is n into 2 pi. Here difference you can see while studying. So you can study it easily. Here we have put up the negative. It is negative part. So you can get to know. So here it is coming over here and it is getting negative. Here it is as it is same. Same applies over here, n minus half into lambda into n lambda. So if we are learning this first nth bright fringe only, then also we are able to get to know about the dark fringe as well. So it is easy to learn all these formulas. So now let us go on the second other part, that is Rayleigh criterion for limit. Rayleigh's criterion for limit of resolution or resolving power it is. So d theta is equal to lambda by a. It is for like first principle minima. Second, limit of resolution d theta is equal to lambda by a. And third is y is equal to d into d theta equals to d lambda by a. Resolving power of a microscope. First, path difference is equivalent to 2a sine alpha. Second, path difference at first dark fringe, dark ring is lambda n. So 2a sine alpha is equal to lambda n is equal to lambda by n. So a is equal to lambda by 2 n sine alpha is equals to lambda into 2 times of Na. So Na is equivalent to numerical aperture. It is numerical aperture. Now resolution power R is equals to 1 by A is equals to 2 times of Na divided by lambda. Now microscope with same luminous point objects. So 2a sine alpha is equals to 1.22 lambda n. A is equals to 1.22 lambda n divided by 2 sine alpha. So A is equals to 1.22 lambda into 2n sine alpha is equivalent to 0.61 lambda n sine alpha equal to 0.61 lambda into Na, that is numerical aperture. So now here R resolving power R is equals to 1 by A is equals to Na into 0.61 lambda. Resolving power of a telescope. Theta is equals to 1.22 lambda divided by D. R is equals to 1 by theta into R. So D divided by 1.22 lambda. So by this, we have completed this chapter as well. Please subscribe our channel, hit the bell icon and do comment. Thank you so much for watching this video.